Okay, here's our video on logarithms, doing growth and decay in this video. We had the previous video, we talked about logarithms in general, so if you want to look at that link below, somewhere below, let's get started. So let's use red pen. So remember when we're doing logs, and here's the log button, there's that log button on the calculator. So for example, if I said log 1000, so logs are base 10, so there is a 10 here on the base. You just don't have to put it down, just assumed. And so, in other words, you would see that subscript, which is the base, and then you would see 1000. And most of the time they have it in parentheses. But when you're doing logs with base 10, they usually don't put the 10 in there. They don't put the subscript 10. Let's change the color a little. Let's use yellow. And of course, this can be converted to index form, because a power used to be called an index. Some people still use it. An index, a power, an exponent, same word. So in index form, we have the base of 10. In this case, we don't know what the exponent is, and we want it to equal 1000. So we have it in this form with the log, writing it with logs, and then the index form. And we know this just by looking at it. We know that x would be 3, because 10 to the third power is 1000. So today we're going to look at growth and decay rates. So let's get a clear page going. All right, and let's change the color. Change it to that color, a little butterscotch color. So again, we're going to be talking about exponential equations, and we'll also talk about logarithmic equations. We'll solve them, especially with growth and decay rates. So let's say here's our first question, and let's say we're looking at population question. That's always something that pops up, the population. And so we want to know the population of some place, somewhere. Who knows what it is? Let's say Asgard, fictional home of the Norse god. So let's say that the population of Asgard was 20 million people, or 20 million gods, before Thanos destroyed it, if you watch the Avengers movie. Or Thanos, whatever. And let's say that it was 20 million people in 1970. Long time ago, right? And we want to know what, and we're doing a prediction here, what will be the population. Let's say we're back in time. What will be the population in, or what was the population, let's say in, well, let's just make it 1990, so give that 20 years. So what, not will, but what was the population in 1990? Big little question mark there. Let's not forget the question mark. So we have to set this equation up. So we'll change the color a little. So we want to know what the population would be. And we set it up with our initial amount is 20 million. So we just can put 20. Now this is a growth question. Obviously it's growth. We want to know that it's not decaying. The population is not declining. It's growing. Or it's projected to grow. So we're then we're going to times this. There's a little times sign. And we do it we always add a 1 to growth. 1 plus the rate, which is 3%, let's say. So let's just say, because we have to add that in, 3% is 0.03. In order to answer this question, we need to know what is the projected growth rate. And we'll say 3%. It could be any percent. We'll just say 3%. And we want it to equal something, because that's the population. So we can rewrite this. The population is going to be 20 times 1.03. And the thing we're missing now is the t, the time. Well, we know the time because from 1970 to 1990 was 20 years. So now we can fill in 20 for t. Change the color. So now we have p equals 20 times 1.03 and then 20 years. And just plug that in the calculator. And so again, the 20 is the initial population. The 1.03 is the growth rate. We're putting a 1 because it is growth. You put a 1 with growth. If there's no growth, you don't put a 1. And t is the time frame. So this will give us a population about, we'll just say 36 million. projected to be, well, it was, if it was this true rate of 36 million people. All right, so I'll keep that up for a couple of seconds. If you want to rewind. And let's add more to this. All right, I'm going to clear this out. Boom, there we go. So let's say, go back to red. Let's say we want to know what the population would be in 2022. What would it be in 2022? So again, the initial population was 20 million. The growth rate is the same, 1.03. But from 1970 to 2022 would be 52 years. So see how we're working this out? So again, that'll be approximately 93 million people if the growth rate stayed the same. All right, let's move on. So if we wanted to determine the year, let's say we want to determine the year that Asgard will have 100 million people. I mean, we just did one where it's 93 million, so it looks like it's going to be close to 52. But let's just get exactly. So in this case, we're going to be logarithmic. Logarithmic. And what we're going to do here is we're going to say the base is the percentage, right, is 1.03. So let me just write this. Let me just give you an example here, and then we can erase that. So if I said 5x equals 25, we did this in the last video. We know this is logarithmic. And we wanted to find x. Well, we know x is 2, right, because 5 times 2 is 25. So this could be written as log 5, subscript 5, because that's the base. The base is always on the subscript. And then we have 25. So in the same case, we're going to be doing this also with this question. We know that the percentage was 3%, was 3% growth rate. So we're going to say, just like we did here, log, the base is 1.03, right? And we want to know when it will be 100 million. When will it be 100 million? So let's change the color. We'll use purple. So what I'm saying here is we want to know when will it be 100 million? That's the population. Our initial was 20 plus, well, times, 1.03, and then we have t. Now, we need to get the 20 out of there, right? We need to do some algebra here. So dividing the 20 on both sides. If we do that, there's our arrow, so you're following me. Now we have a 5. 5 is going to equal 1.03t. And then we could put this in, put a little arrow like this. We could say log 1.03, and then in this parentheses over here would be 5, because that's the answer. We're trying to find what t is. All right, so let's review this again. So we want to know what it will be, what the population would be in 100 when it will reach 100 million, and the initial was 20, so we have to get it into this form here, right over here, this form. So let me clear this out. Let's do it over so I can have more room. All right, so why don't I use green? Why don't we use green? So we have, initially it was 100 million. When will it reach 100 million? Our initial was 20 million times 1.03. That's the growth rate. And we want to know when as the t. And what we did is we divided 20 on both sides because we're trying to get this form where we just have the rate, the base, and the time. And what we can do here then is we can say And this, by the way, would also look like this. 1.03 t equals 5, in case you like it that way better. And this is like saying log 1.03 5. And if you're confused with this, again, we did it in the last video. And then from this, we're going to bring the t down. And we're going to make this all log. Log 1.03 equals log 5. We make them all logs. And then just do some algebra. You're basically going to divide log 5 on your calculator. Remember, press the log button. There's the log button. Log 5 divided by log 1.03. And make sure when you're doing it log, you press that log button, and you make sure you put the parentheses around the 5. Sometimes you don't have to do that, but make sure you look at that, put the parentheses at that. And you know that t would be about 54 years. All right, let's use a temperature question. So I'll clear that out. Give you a couple of seconds if you have to write something down. Clearing it out. And let's do a temperature in Asgard. So in Asgard, they drink mead. Say we're going to drink some hot mead. There we go. Let's drink some hot mead. Honey wine. You probably don't want to drink hot mead, but who knows? So let's say we want to know the temperature, T, the temperature. And let's say the initial temperature of this hot mead when it came out of the oven was 180 degrees. And we'll just say Fahrenheit. And we want to find the temperature in Fahrenheit. And of course, it could be in Celsius. Doesn't matter. And we're looking now at let's say in this question, we want to know how long the temperature, how long will it take for the temperature to be, 160 degrees, let's say. That's a question we can ask. We can say something like that. Or we can also say, a couple of questions here. How many minutes, because that's the same thing. Or what was the temperature? Let's put it this way. What's the temperature? What is the temperature after, let's say, 5 minutes? That's a better question. So let's do that one first. We'll do number 2 first. Should have made that number 1, and then we'll do number 1. So let's say the initial temperature is 180. And let's say that we already know that the rate is going to be 0.87. We know. So this is a decline. It's going down. It's not going up. That's why we don't have the 1. There's the rate. And we'll put it in parentheses. And we want to know how many minutes. So let's write this over here. The temperature, what will the temperature be after 5 minutes? So we have 180 degrees, this initial temperature when it came out. We have the rate already, 0.87. And we want to find the minutes. Plus, I'm going to add 70 here, and that is room temperature. So you have to add that to the room temperature. So we want to know what it would be the temperature after 5 minutes. So you substitute M for 5. So now we'll have the temperature equals 180 times 0.87, 5 plus 70. And if you plug that into the calculator with the 5 there, the temperature should be about 160 degrees. Almost ready to drink, right? So usually people like to drink their tea at about 150 degrees, right? Which brings us another question. That's why I made the second question first. How long will it take for the temperature to be 160, let's say? Maybe you like it at 160. So how can we do that? Well, let's write that down. Let's get a different color pen going here. Let's do green. I'll see if I can fit it in here. So I'll make it smaller. So we want to know when the temperature will be 100. Let's just say 150 for now. When will it be 150? Because that's comfortable drinking. So the initial temperature was 180. We already know our rate, 0.87. We don't know M because we want to know how long it will take to get to 150. And don't forget, we also have the room temperature of 70. So we're doing algebra now. Let's clear this out. We want to make it clear, right? So we're going to get rid of that 70. Whatever due to one side, due to the other. All right. Let's change the color so you can see it more. So now we have 80 equals 180 times 0.87. We don't know what m is, but we're getting close. Of course, we want it in the form where the rate and the exponent or the index are alone. So let's get rid of that 180 by dividing. Remember, we want to do the opposite operation. And if you divide 80 divided by 180, put a big arrow over here so we're continuing, you're going to get about 0.444. We'll just say 0.44. So now we have 0.44 equals 0.87 m. Or if you saw it this way, 0.87 m equals 0.44. Now remember, when we're turning it into logs here, we're putting the m down. M log 0.87 equals log 0.44. Dividing it out. And rewind the tape if it's getting a little confusing. So on your calculator, you're going to press in log 0.44. Don't forget the log button. Divided by log 0.87. You have to divide that out. And when you do divide that, you're going to have m is going to equal about 5.89, which is about 5 minutes. Well, let's just say 5.9, just to round it up. 5 minutes and 54 seconds. Because, when every point is 6 seconds if we're doing minutes. So 9 times 6 is 54. So 5 minutes, 54 seconds to get it to 150 degrees. All right. Don't forget to rewind if you have to, just to understand what we're doing here. Now let's do one with, let's do one more. So let's clear that out. And we'll use blue. Why not? Let's say we're doing a video like I'm doing now. But let's say there was a nice video out there and the video went viral. Who knows? So not this video, right? This video is not going to go viral. But there was a video that went viral. Maybe it was when Thanos defeated the Hulk in that movie. And we're going to see, we want to know a question of how many days. So we're going to use days. We'll use D for days. Why not? Seems obvious. And views. What should we use for views? Q, right? No. V, right? So we have that. And we want to know, let's say that when this video came out, whatever this video was, that it initially had 500 views. And it's growing. So there's a growth rate at 20%. 20% growth. So we want to know how many views would that be, right? So if we have views equal 500 times 1 plus 20%, 1 plus 20%, 0.20, and then we'll put D. So now we can make a question with this. So let's say in this question, we want to know when the views will be, let's say, 1 million. When will it get to 1 million views? So we're going to put 1 million. 1 million views will equal the initial views, 500, times the rate. 1 plus 0.20 is 1.2. And so how many days would it take to get to 1 million? So we have to clean this up like we've been doing, right? So we're going to clean it up. We're going to divide the 500 on both sides. Clean it up. And now we're going to get 2,000 equals 1.2 D. And if you're used to it the other way, in index form, 1.2 D equals 2,000. Now with logs, we can say this. We can say that D log 1.2 equals log 2,000. So go ahead, see what you get with that one. right, so pause the tape if you need to, if you care. So again, just doing a little algebra here. We're going to divide the log 1.2 on both sides. And just put it in the calculator. If you did that, the number of days would be around 41.689. So we'll just say roughly 42 days. So it'll take about 42 days to get 1 million views if it was at that rate consistently. Of course, that doesn't really happen in the real world, right? They go up and down like a roller coaster. All right, in the next video, we'll talk about compound interest and more about logarithms.